Let's go through the code 802. Find the eventual safety states. For this question, it gives us a directional graph of n nodes. So we know the length of this graph is n, right? And it has a zero index to the integer array, where graph I is an integer array of nodes adjacent to node I means that there is an edge from node I to each node in graph I. So for example, the index 0, it goes to 1 and 2. So each return array contains all safest nodes of the graph. So what is safe node is that after some kind of moving, it will lead to a terminal node. That means it will not loop in a circle, right? So we'll see for this question, the 6 is not in a circle, so it's a safe node. And 5, all of the nodes were it does not have an outer bound, so this one is safe too, right? 4, it just have one root, it goes to 5, and because 5 is safe, so 4 is also safe. And also 2, right? 2 is leading to 5. There is only one outbound route. So 2 is safe as well. For the other one, for example, 1, right? 1, it have multiple options. For example, if it goes to 2, it will go to safe state. But it can go to 3 and go to 0, then loop back to 1. So there is a circle here, right? So for this question, what we do is that we know for those kind of nodes which have the out degrees is 0, this is in set state. So we put all of the nodes which is out degrees with 0 into a queue. And also when we pull back, right? So for every node leads to that node, their out degrees subtract by 1. And if for its parents, the out degrees equals 0 in Q again. So when we pull out those kind of out of the Q, we added that to our result. So this is also topological sorting, but we are doing just for other bonds. So let's write code for this. It's kind of straightforward. So let's say let's have a map, okay? Map integer. Actually, this is graph, so we don't need to compose graph again. So we just have this one out degrees equals u dash map. So let's say for int I plus then I smaller than n I plus plus. I have out degrees, but I and the graph dot size, right? Graph the dot length, graph the I dot length means how many out degree it has. So we are going to have a list of integers result equals new array list, right? So we also do Q integer Q equals new array that array depth. And we'll say for every node which is have all degrees to be 0 for n I equals 0 I smaller than n I plus plus. If all the degrees with I equals 0, then we just put this one into Q of alpha I. So what we are going to do is that this Q is not empty, right? Okay. It's not empty. We'll have input current equals Q of 4. And of course, we need to add this to this up, right? Because this one don't have all degree anymore, so it will be in a safe state. And for every child, so that is actually it's so we also needed to have a map, right? So graph that is 0 will go to 1 and 2. So how many nodes go to 1, right? How many goes to 2? We also need to create a map, right? So we also need a map to create a integer, list of integer. We call graph, the communal hash map. Let's have this graph first. New array list. Yeah. So we iterated the graph to we already have graph we call map. We iterated the map for int graph int next graph for int equals there less smaller than n plus plus. We'll have graph map put graph actually which we have for in let's say next in graph I map put with it with add map, right? So this is actually the inbound node. So for every it connects in map with current. Let's say it's all degrees, right? All degrees equals map with next, right? So we'll have all degrees minus minus. So equal all the degree equal to 0 in Q, right? Q after next. We'll also update this map, the all degree map, so that was all the degrees but next. Okay. In the end, we just return result. So this is just a topological sorting. This is not a map. Should be out Greece. We need to sort this one in ascending order. Okay. Result collection sort. Result. Okay. Okay, so this is the topological sorting. And as we talk about for the directed graph, we should be able to use a visited array, right? And also, this question, this give an array. You say that 0 goes to 1, 2. To do the topological sorting, we have to create a map, right? But for this question, if we use a DFS way, we can, because we already have this graph, we don't need to compose this map again. Okay. So what do we need is that we don't need a queue, right? We need a queue. So let's say here there is some kind of circle in it, right? Some kind of circle in it. We'll say for every node which is in the circle, it is not safe. And also, if there is some kind of node, it goes enter the circle, it's not safe as well. Only those kind of nodes which not go to circle, or goes to a node which does have not have outbound, it is safe. So we can try to have ability, right? Visited array have one, 0 to be not visited, 1 to be visiting, 2 will be visited. And also we use this one to detect a circle, right? So if we find a 1, that means this node is in a circle. So when we DFS, right? DFS, and we do the backtracking for all of its parents. We set as unsafe. Okay. So you can write code for this. So let's say we have inter relative equals new inter a, right? So let's say that it is 0 means not relative, 1 means relative, and 2 means relative. Boolean. Let's create a Boolean for the safe. Okay. Equals new Boolean. And let's set all of the initial states as safe. And we try to detect a circle, right? When we find the node, for example, next is 1. That means when we do the backtracking, we can backtrack every node back to be unsafe. So we can have arrays here, say true. Okay. So what we're going to do is so in I post there I smaller than I plus one. So I say if this is not visited, if visited I equals to 0, we are going to have the best graph I visited. Also, we need to update this safe array, right? So in the end, what we are going to do is that we are going to have a list of result equals new array list. So we just put all of the safe one into list for print and push there. That's some of the n right plus plus. If safe, we have the result at right. We don't need to have sort return result because we are iterated from 1 to n. So so here we are going to have started void. We just because we pass in this safe array, someone has just have this DFS return boolean, right? Boolean means previous to a cycle or unsafe or safe whatever. But we can do it anyway, right? But just like we already create a safe array, so we just put DFS here. We have int graph in the int I, and this visited array, right? Visited array now also boolean safe, right? Whether it is safe or not. So what I say if visit equals to 2, right? That means we already handled this kind of node. We just return, don't need to do anything here. And if visited I equals 1, right? Means we meet this node again. That is, for example, A goes to B, goes to C, goes back to A, right? We set this one as 1, 1, 1. We meet this one again. We meet a circle. So that means if it is in the circle, that means it's not safe, right? So say I equals to false. And also we are set this relative I equals 2, right? Because we already handle it and return. So we set visited I equals to 1, right? And for every child, for in the child in graph I do something, right? And after we do something, we'll have visited I equals 2, right? So we are saying well DFS is child DFS graph related, right? So that means that after doing this kind of DFS, we know this child whether it is safe or not. We know every upstream of a circle. If it is not safe, right? So every upstream will not be safe. So let's say if, and if it is if it is not safe, right? We cannot say it is safe. Just we'll say if it is not safe, substring, it is always not safe. But we can only say after this that every child is not safe. Then every child is safe. Then we'll say it is safe. Right? So we can say if any of the safe child equals false, we'll have safe I equals to false. Right? We can return. Don't need to, because we already know whether it is safe or not, right? So if we return, if we go here, that means we'll say this safe is true, right? We don't need to update actually. Because that is our initial value. So this will be the DFS way doing this.